Let's go to that slide, Rick, and look at the weather data that you've collected. So if we look at Worcester, Mass, can you just talk about this slide right here?
Sure. So Worcester, the way that this slide was made up is we went to the engineering books, and over the last 50 years of collected data, there's 4,700 hours a year that are below 50 degrees. So of that, about 65% of that time is above freezing.
Okay.
So if 65% of the time is above freezing, and that's when our systems are most efficient, then that represents a huge amount of money that our homeowner can save on their energy bill.
Okay. So what we're saying here is below 50 degrees is the heating season, and the majority of the heating hours are well above 20 and 30 degrees. We've got 1,280 that are 40 to 50, 1,798 that are 30 to 40, and 977 that are 20 to 30. So how does this relate here to that COP, coefficient of performance?
Well, in each of these ranges, we are going to have a different efficiency. So as opposed to oil and propane and gas, whose efficiency stays constant because their equipment resides in the basement, our system, as the temperature goes down, so does our efficiency. Now the good news is it's not as cold here as people think that it is. So as we just discussed, 65% of the time we are at our highest efficiency of the year.
So where is that COP of 3? You said that average COP where we're going to be. What temperature range is that?
That's going to be in the 30 to 40 degree range. It's going to be a coefficient of performance of 3.
There's the bulk of our heating hours. That's going to be that sweet spot and above, and then we've got 977, 582, and 99. Now you mentioned crossover point at 20 degrees. What does that mean?
So what that is assuming, a crossover point, the idea of a crossover point is above a certain temperature, it's more efficient to use another source of fuel. Below a certain temperature, it's less expensive, say, to use oil or propane. So really, the temperature, the crossover point is going to be in the 20 to 30 degree range for natural gas. So above whatever, depending on what your actual prices are at the time, there will be a point where it's less expensive to use Mr. Slim than your gas furnace or your gas boiler.
So the COP of 2 that we spoke about, where is that?
That's going to be down around the 10 to 20 degree range.
Okay. So COP of 2, okay, we said propane and oil and electric were always going to be more efficient there.
Correct.
Okay. So it's not, as long as we can keep up with the demand, we're more efficient at 10 to 20 degrees. Okay. Natural gas, we're more efficient 20 degrees and above in most cases.
Correct. So for, in this case, 670 hours a year, it's better to use your gas system than it is to use our system.
So let's look at some other areas of Massachusetts. Let's just look at Boston, for example, real quick.
So Boston, the numbers are similar. Really, the difference is going to be that 74% of the time we are above freezing in Boston.
Okay. So warmer area of Massachusetts.
So a larger part of the season, it's going to be more efficient to use us than any other source.
Okay. So just for fun, let's look at, do you have a Vermont, Burlington, Vermont?
So here's Burlington, Vermont.
Okay. So 53% of the time we're above freezing and more efficient.
Well, the thing that I like about Burlington, Vermont is many people view Burlington, Vermont as a really cold part of New England. So their temperature, when you design a heating system up in Vermont, it's your design temperature is minus 11 degrees up there. Well, most people have this view of heat pumps that we don't work when it's cold. But that's actually not true. We have a system that will work to minus 13 degrees. So even in Burlington, Vermont, we could provide heating over 99% of the year in Burlington, Vermont, whereas most people just assume that heat pumps stop working when it gets down to freezing. But as technology changes, our systems start performing better and better at lower temperatures.
Okay.